So today we're going to talk about congruent triangles. All right, this is a setup for what we're going to do the rest of the chapter, which is all about proving congruent triangles. So today we're going to talk about just what it means to be congruent triangles. What's congruent mean? Who remembers what the word congruent means? Same, right? So congruent triangles are triangles that are the exact same. Section 4.3. So if I look here, I got three vocab terms. The first one, corresponding angles. We talked about the word corresponding before in terms of parallel lines. Do you guys remember talking about that? Remember something like this? Those are corresponding angles. What did we mean when we said corresponding? We talked about in parallel lines, we said corresponding was like the same spot or same position, right? Yeah. So same thing here. Corresponding angles with polygons, they're angles that are in the same position. So for example here, if I have, two right triangles here, well, the right angles, those would be corresponding angles because they're in the same position in that triangle. And then I have corresponding sides. Well, if corresponding angles are the same angle positions, corresponding sides are the same side position. So it's the same thing there, just the side positions. And then congruent polygons are two polygons whose corresponding sides and angles are congruent. So they're congruent if the sides and angles are all congruent. So here's what we're looking at today. We're going to look at questions like this. Okay, I have some congruent triangles. It says the triangles are congruent, they have the same size and shape. Their corresponding parts, the angles and sides that are in the same positions, are congruent. How do we label congruencies? What do I call those things? Those are called tick marks, right? Or congruency symbols. So if that one has a 1, which one is this congruent to? Yeah. So we're saying CB is congruent to KL. So if you look here, BC is congruent to KL. All right. The same is true for angles. If I notice here angle A, which one would angle A be the same as? Angle J. So angle A is congruent to angle J. So I can show they're congruent by their tick marks. Again, to identify corresponding parts of congruent triangles, we can also look at the order of the vertices. So for example, I have triangle ABC is congruent to triangle JKL. If A comes first, what do you suppose A is congruent to? J. The order is important there. Okay, they don't just always put it in a random order. They put it in an order where the letters match up. Okay, they are corresponding. So let's look at number 1. It says given triangle XYZ is congruent to triangle NPQ. Identify the congruent corresponding parts. So I'm going to start with angle Z. So here's angle Z. Notice how many tick marks does angle Z have? 2. So I'm looking for the one in the other triangle that has 2 tick marks, which is angle Q. So angle Z is congruent to angle Q. Number 2. YZ. So number 2 says YZ. So YZ has how many tick marks there? 2. So what is YZ going to be the same as?
PQ.
PQ. Now notice, did we say QP or PQ? PQ, right? Because Y is Z, so we went from the first one, Y had a 1 tick mark, so P to Q, right? So I'm going to go PQ. Nice job. Angle P, number 3, angle P. Which one's going to be the same as angle P McCoolidge? Angle Y. Nice job. Number 4, Brock, angle X. What's angle X going to be the same as? Angle N. Nice job. Number 5, NQ. So I'm looking at NQ here. What's NQ going to be the same as Bannister? That'd be the same as XZ. Nice job. And last one I have is PN. So we look here at PN. What's PN going to be the same as Blake? Maybe YX. Now again, make sure you label these correctly with segment lines above them and angles out in front if they're angles or segments. Oop, no, there's angle. So I can use that information now for congruency triangles to find missing values or angles.
Nice.
Okay. So number 7 says, once we find angle x, or sorry, once we find x. So notice I have given the two triangles are congruent. I want to find x down here. Well, x is a part of E. Well, how can I find x, Chris?
You put 4x plus 6 equals 90.
Why do I say 4x plus 6 equals 90?
Because E is congruent to R and R.
Yeah. It shows E and R are the same term, so that means they are the corresponding angles. R shows is a right angle. Right angle means 90 degrees, right? So I'd say 4x plus 6 equals 90. From there, I can solve for x. Subtract 6 to both sides, divide by 4. I get x equals 21. Nice job. I can do number 8. Number 8 says, once we find y. Well, y is shown over here with t. It says 5y minus 2. What else can I use to help me with t? What's t going to be corresponding to? So if I look at g, what's g?
28.
So how can I work that one out?
5y minus 2 equals 28.
5y minus 2 equals 28. Add 2 to the other side, and divide by 5, and I get y equals 6. Okay. So next one says, now I want to find angle F. So I want to find angle F here. Well, there's angle F. All I know is angle G is 28 degrees. But what else do I know about this triangle? What's E? Why is E 90 degrees? Because it's the same as R, right?
Yeah.
So if that one's 90 degrees, well, how can I find an angle F then?
Subtract it by 180.
Yeah, 180 minus 90 minus 28. Which means angle F is going to be 62 degrees. Good work. And then the last one is I want to find ST. So I want to find ST here. What's ST going to be the same as? So what am I going to do with those two terms?
Equal up to each other.
Z plus 4 equals 3z minus 8. Subtract z over. Add 8 over. What do we get? 12 equals 2z. Z equals 6. Is that my answer? No, plug it in. What's 6 plus 4? ST is going to have to be 10. Okay, so I can use the congruency parts there to work through and find missing angles or missing sides. All right? Try these 4 on your own. Now it says, in baseball, home plate is a pentagon. Pentagon ABCDE is a diagram of a regulation home plate. The baseball rules are very specific about the exact dimensions of this pentagon so that every home plate is congruent to every other home plate. If pentagon PQRST is another home plate, identify each congruent corresponding part. So yeah, there's no other pentagon up here. You have to just look at the way they are and then match their corresponding parts accordingly. All right, so take a couple seconds, try these 4 on your own. All right, so let's look at this one. Number 11, S. S is going to be the same as what, Katie? Angle D. Nice job. Number 12, angle E is going to be the same as what, Anderson?
T.
Angle T. Number 13, EA. What's EA going to be the same as Luis? TP. And 14, TS. What's TS going to be the same as Heston? ED. TS will be the same as ED. Nice job. All right, last one. Try these 2 here. So it says, given triangle DEF is congruent to triangle LMN. Find each value. Now here's the thing about this one. I'll help you get started here. First thing it wants me to do is find angle L. Well, angle L tells me it's x plus 15, right? But I don't even know L would go the same with D. Does everybody agree with that?
Yeah.
It doesn't give me anything about D, though, does it? But what do I know with x over here? I know 2x plus 3. What's ED can be the same as? 53. So can I solve for x that way and then plug it back in? Yeah. Okay, so on this one you have to find some other information first, solve for it, and then plug the information in. Same is true on the next one. I need to solve for EF, which is over here. Well, to solve for y, I need to find y from f and angle n here.
B3.
All right, so take a couple seconds, try these on your own. So 15, I need to find angle L. In order to find angle L, I need to first find x. So to do that, I would say 2x plus 3 equals 53, because I know those two sides are the same. I get x equals 25. I now plug that into my angle. 25 plus 15, angle L is now 40 degrees. Okay, next one says, let's find EF. Well, EF is 1.5y plus 1.3. I don't know why. I know F and N are the same though. So I would say 5y equals 120. Solve for y.
Oh, okay.
Y equals 24. Now I take y equals 24, plug it in to 1.5y plus 1.3, and I get a side measure of, I believe it is 37.3. Okay, so again, this one, yeah, it's a little bit tougher because you have to find some other work first, but you can still do it. Okay. Here's your assignment.